Trigonometric equations. First problem asks us to solve for x. They all ask to solve for x. 2 cosine x minus 1 is 0. If you subtract two quantities and you get 0, that means they differ by 0. They're the same. The instant I see one thing minus another equals 0, I write down the two things and I put two horizontal lines in between them. Those two things are equal. There's no way that that's not 1. Because 1 take away 1 equals 0. 11 take away 1 is not 0. 1 take away 1 is 0. Okay. Dividing both sides by 2, I learned that cosine x is 1/2. Well, in just 360 degrees, from 0 to 360, where does cosine x equal 1/2? Well, cosine deals with the horizontal, the adjacent. The adjacent is only positive. 1/2 is positive. Adjacent is only positive over here. So if you have an angle in the first quadrant, call it x, cosine of x could be 1/2. And that would be 3. And well, like, oh, I remember that triangle. That's our 60-degree triangle. Or we can be in quadrant 4. That is, this can be the angle, and fair enough, the opposite is going down, so it's negative, but the adjacent is still to the right, is positive. The hypotenuse is still 2, and this is a 60-degree reference angle, making this angle 300. So we know that x can be 60 and that x can be 300. But something's wrong here. I suspect that there are many more answers. Because I know the cosine graph, it keeps going to the right forever. And it even goes to the left forever. Equaling 1/2 happens frequently. Here and here and here and here. And forever to the left, to the right. And here and here and here. And of course here and to the left forever. There's many answers. This answer here, that came from 60 degrees. This answer here, that came from 360. For the record, here's 360. This here is 1 period. Now, the next period, it also is going to have two places where it equals 1/2. This place, it's not going to be 60, but it's going to be 360 plus 360. This one isn't going to be 300, it's going to be 300 plus 60. That's not true. From here to here is 360. It's going to be 300 plus 360. This one matches with that one. It's going to be 300 minus 360. This one's going to be 300 minus 2 times 360, minus 720. Okay. Don't think what I said was correct. This one, when I do my arithmetic, is negative 60. This one's going to be negative 60 minus another 360. This one comes from here, which is 60. This is going to be 60, take away 360. This next one here, so this is negative 330. This is going to be negative 330 minus another 360. That is the two answers that we got. 360. We can add and subtract any integer multiple of 360. The final answer will be x can be 60 degrees plus 360k, or 300 plus 360k, where k is an integer. Remember, integers can be negative. So this is an awful lot of numbers. X equals 60 plus 360k. This is an awful lot of numbers that I'm writing. I mean, if k is 0, it's 60. If k is 1, 60 plus 360 times 1 is 420. If k is 2, 60 plus 720 is 780. 60 plus 1080, I'm adding 3 k's, 1080, that's 1140. The next one would be 1500, I'm pretty sure, etc. And k can be negative 1. 60 plus 360 minus 1 times negative 1 is 60 minus 360, which is minus 300, minus another 360, minus another 360, minus another 360. This here is an infinite number of numbers. One for each integer k is an infinite number of integers. Same thing with 300 plus 60k. This is all the solutions, not just the ones between 0 and 360. It is all the solutions. And in terms of writing down the answers, you don't need to put this. But I think I was clear why I wrote it. I want you to see that what I have boxed there is a lot of numbers. Okay, let us try another equation. Suppose you have the equation that tan x plus 1 is equal to 0. Well, if you add two quantities, then you get 0. The numbers are of opposite signs. For example, 7 plus negative 7 is 0. Negative 8 plus 8 is 0. 2/3 plus negative 2/3 is 0. E to the pi, or negative e to the pi, plus e to the pi is 0. Notice the numbers just differ by a sign. This is e to the pi, this is negative e to the pi. We add them, we get 0. They're opposite signs. If I tell you that x plus 4 is 0, and that's 4, well then guess what? That's negative 4. Okay? It amazes me how teachers will teach about additive inverses. They're like, well, what do you add to 2 to get to 0? And every student in the class will say negative 2. And then, what do you add to negative 3 to get 0? And every student in the class would say 3. But then, when it comes to using that talent, the teacher will now say, oh, you take away 3 from both sides. And it's not wrong, but to the teachers out there, why did you spend time teaching about additive inverses if you're not going to use it? Spend more time on solving linear equations. Spend time on things that you're going to use. I'm adding 2 quantities and I'm getting 0, and that's 3. That's negative 3. Taking away 3 from both sides, it just baffles my mind why you would teach additive inverses, but then when you get to use it, you don't. You always get quadratic equations. You factor them, equals 0. You get x plus 3 is 0, or x minus 4 is 0. Additive inverses. You add 2 quantities, you get 0. The 2 quantities have to be different signs. You subtract 2 things and you get 0. Those 2 things must be equal. Okay, so tangent of x is negative 1. Let us find out where in one period we get 1. Now, one period of the tan graph. Well, just for the record, one period of the cosine graph did go from 0 to 360. That's why I looked from 0 to 360 in the last problem. Same for sine. But what about tangent? I know tangent goes like this, and then it repeats this again. Here is negative pi over 2. Of course, that's 0. That's pi over 2. And this here is 3 pi over 2. So do you need to go out to 360? Now, this number right here is pi. Between 1 pi over 2 and 3 pi over 2 is 2 pi over 2's, which is just pi. 2 pi over 2 is just pi. Now, this portion and this portion, that's one period. Okay, this keeps repeating. This keeps repeating. Okay, for example, after here, this should repeat. And look at it. That's what's That's what's repeating. And then this, that is what's repeating. And I would normally say a period goes from negative pi over 2 to pi over 2. But let's just go 0 to pi. That is, we only have to look at the top half of the grid, the XY plane. XY. Which angles have negative 1? Well, you're not going to have negative 1 in the first quadrant because the opposite's positive and the adjacent's positive. In quadrant 2, you can have the opposite positive and the adjacent negative. That's looking good. And one way of getting negative 1 is 1 and negative 1. That makes that 45 degrees. It's 180 minus 45. So one answer is 135. And I'm claiming you don't have to go any further. Now, if you went into quadrant 3, adjacent is negative and and opposite is negative, and when you divide the two, you'll get positive. But in quadrant 4, you have positive and negative. This is also 45 degrees. So this angle will be 360 minus 45, which is 315. I claim that you don't need that. Let's see if I'm wrong or not. X is 315. Okay. So I claim you don't need the bottom one. So now, the question is, what is the answer? Because that's only one answer. -1, let's see, -1 is at 135. -1 is, say, right here. So we found that angle. But you know what? Remember that one period, it goes from 0 to pi. It's pi. So I claim that you can add on any multiple of pi. Okay? You can take away pi. From here to here is pi. There it is again. Okay? You can add pi. There it is again. You can always add pi. Well, do I pick up all of those numbers? Well, isn't 315 135 plus 180 plus 180 plus pi k? But 180 is pi. So, you know, you have pi plus pi k. You just have k plus 1 times pi. Okay, I mean, if you had 3x plus kx, you would have 3 plus kx's. We have, instead of x, we have pi. 3 pi plus k pi, that's 3 plus k pi. You know, even if I had 3 pi plus k pi, excuse me. Even if I have pi times k, these two are equal. It is still 3 plus k pi. So if I just have 1 pi and I add k more pi, it is an understood 1 there. I have 1 plus k pi. Whether I write k pi as k pi or pi k. But this is still any integer. I can get this to be 0, let k be -1. I can get this to be 1, let k be 0. I can get this to be 17, let k be 16. I can get this to be -9, let k be -10. This is the same as this one up here. You don't need to go other than from 0 to pi. And the only time that tangent of x is equal to -1 is at 135? So it's 135, x can be 135 plus 180k, or this is 45 times 3. Pi over 4 is 45 times 3 plus pi, 180 is pi. This is one of the two ways you can write the answers. When it comes to the tangent, just go from 0 to pi to find an answer. from 0 to 90, the tangent has to be positive. So if it's negative, it's not 0 to 90. And from 90 to 180, the tangent is negative. So you're only going to get one answer. You're going to get one answer and add 180k or pi k to that. Let us try yet another one. Suppose you have sine squared x is equal to 2 sine x plus 3. 2 sine x plus 3. This here is a quadratic equation. Let's bring everything to the left. So, sine squared x minus 2 sine x minus 3 is 0. Now, whether you make this substitution or not, you need to see the quadratic formula. If I let u equal sine x, well then that would be minus 2u minus 3. But this is u squared. And it still equals 0. Can I, and there's an understood one here, can I think of two numbers that multiply out to negative 1, but add up to negative 2? Okay, so there's something that's bothering me. Don't ask why I wrote negative u. I'm supposed to write down negative 3. Can you think of two numbers that multiply out to negative 3 but add up to negative 2? And if you can, you put those numbers next to u. The answers are negative 3 and positive 1. These two numbers, they multiply out to negative 3 and they add up to negative 2. So either u is negative 3 or u is negative 1. But u is sine x. So either sine x is negative 3 or sine x is negative 1. Well, sine x is negative 3 here. Okay, that's gone. When is sine x negative 1? Well, let's look at one period of the sine graph. It equals negative 1 right here. 0, 90, 180, 270, 360. X is equal to 270 degrees. And it's going to repeat. Plus 360k. Another way of writing it, and that was the only answer. Another way of writing it is, this is 3 times 90. Pi is 180. Divided by 2, I get 90. Triple it, I get 270. Plus, that's 2 pi k. I's are 1. They're not two different answers. They're the same answer. And I guess I didn't do it in the last problem, but I should have. We should say k is an integer. K is a member of the integers. Or write it in words. K is an integer. So what happened is, if you go another 360 degrees, I shouldn't have gone as high or as low. If I go another 360 degrees, what happened is I hit another one. And that distance will be 360 degrees. And if I go 360 degrees to the left, right here, it hits again. And the distance from here to there, 360 degrees. There's your answers to this problem. let us consider the next one. Suppose you have that sine squared x is 4 minus 2 cosine squared x. Well, remember that sine squared x is equal to 1 minus cosine squared x. So 1 minus cosine squared x is equal to 4 minus 2 cosine squared x. So I bring this over and I'll have 1 cosine squared x. I bring that over, I get 3. 4 minus 1 is 3. So cosine x must be the square root of 3, and there is no solution. You can have the cosine of x, the cosine of an angle, being bigger than 1. That's bigger than 1. I mean, 1 times 1 is 1. What do you multiply by itself to get 3? I don't know, but it's more than 1. 11 times 11 is 121. 1.1 times 1.1 is only 1.21. I know that 15 times 15 is 225. So 1.5 times 1.5 is that. That is, the square root of 2.25 is less than the square root of 3. And it is 1.5. So this here is bigger than 1. The square root of 3 is bigger than 1. Can't take the square root of a number. You can't take the cosine of an angle and get more than 1. Okay. Now, what if you had this problem? Slightly different, just a little bit different. Want to get you to think. Sine squared x is 4 minus cosine squared x. Well, the left side is the same as 1 minus cosine squared x, and it equals 4 cosine squared x. I hope you see that there's a problem. This is a number. We don't know what the number is yet, and we know a little bit about it. It's between -1 and 1, but it's a number, and this is the same number. If you and your classmates had a calculator and you put in 1 and your classmate put in 4, and then you both hit minus and you put in the same number, you took away the same number, you can't get equality. You're taking away a number from 1, your classmate is taking the same number away from 4. Okay, let's make the numbers a little bit bigger so it's more realistic to what I'm about to say. If you have $100 in the bank and I have $80 in the bank, and we both take away the same amount, how can it be equal? You're going to have $20 more than me. If we go into the bank together and you have $20 more than me, and we both take out the same amount, this unusual amount, you're still going to have $20 more than me when we leave. Okay, there's no way to solve that. If you want to try to solve it, that's fine. So let me bring the cosine x's to the right. So I'm going to add cosine squared x on the left, giving me just 1. And I'm going to add cosine squared x on the right. And oh, it's going to cancel out here. And I get 4. The only possible way this problem can have a solution is if 1 equals 4. It's not going to happen. 1 does not equal 4. Okay. Let us try the next problem. Suppose you have 2 sine 3x minus 1 is 0. Like I said before, if you subtract two things and you get 0, immediately write down the two things and put two horizontal lines in between them. They're equal. So sine 3x must be a half. 2 times a half gives me 1. Okay. So now, what can 3x equal? Well, between 0 and 360, the sine equals a half when the opposite is positive. It's going to equal a half in either one of those quadrants. So 3x can be, let's see, the sine of 3x is 1 over 2. That's going to be square root of 3, so that is 30 degrees, excuse me. That's going to be 30 degrees. This is also going to be 30 degrees, which means that 3x is 150. Okay, so 3x can be 30 degrees, 3x can be 150 degrees. But again, you can add any multiple of 360. Now, divide by 3. Add on the multiples of 360 before you divide. 30 divided by 3 is 10. 360 divided by 3 is 120 times k. X divided by 3 is x. 150 divided by 3 is 50. 360k divided by 3 is 120k. K is an integer. And integers are positive and negative. There are your two answers. Suppose you are given that the cosine of half x is radical 3 over 2. Okay. Cosine deals with the adjacent and is positive. That means it's to the right of the x-axis. You can be in quadrant 1 or you can be in quadrant 4. Cosine is adjacent over hypotenuse, so that's 1, and this angle is 30 degrees. In quadrant 4, the adjacent is radical 3, hypotenuse is always positive, in this case 2, and that's negative. But nonetheless, the cosine of this angle, which is the cosine of that reference angle, is still radical 3 over 2. Since the reference angle is 30, this angle is 330. So x over 2 can equal to 30 plus 360k, or x over 2 can equal to 330 plus 360k. So multiplying both sides by 2, we get 60 degrees plus 720k. Multiplying by 2, we get 660 plus 720k. Not sure how I wrote 720 wrong up there. I'm sure I said it, but more importantly, here are the two answers. The sine of 3x is 1. Okay. at 90. Plus multiples of 360. I don't care what the angle is. The angle must be 90 degrees plus multiples of 360k. Dividing by 3, we can find out what x is. 30 degrees plus 120k. Let's see if this makes sense. Suppose k is 0. So then x will equal to 30 degrees plus 0. So 3x will be 90, and yeah, the sine of 90 is 1. That's what I said. The sine of 90 is 1. What if k is 1? So we get 30 plus 120, which is 150. So that's what x is. So 3x will be 450. And the sine of 450, well, you can take away 360 from that. In other words, 450 is 360 plus 90 more. This is just the sine of 90. Well, I keep telling you that's 1. What if, say, k is negative 1? K is negative 1. So we have 330 minus 120, which is negative 90. Well, the sine of negative 90 okay, so excuse me for a second. X will be negative 90. So 3x will be negative 270. And the sine of negative 270, well, the sine has a rule. The minus can come in front. So it's minus the sine of 270. 90, 180, 270, 360. The sine of 270 is negative 1. So you have negative this, and this is negative 1. So yep, I get back 1. Seems to be working fine for me. On an exam, you can check that. So what if we did a similar problem? Instead of the sine of 3x equaling 1, we say x over 5 equals 1. Well, again, I'm just concerned about one period. And in one period, the sine equals 1 at 90 degrees. For the record, I could have used any other period I liked. It just has to be a complete period. And in that period, see where it's 1. So, x over 5 has to be 90. Plus any multiple of 360. If it were tangent, I would add multiples of 180. Multiplying by 5, x is 450 plus 1800k. For the record, this is pi over 2 plus 2 pi k multiplying by 5. I get 5 pi over 2. Multiplying by 5, I get 10k. So that's one answer. That's another way of representing the one answer. As long as we multiply by 5 correctly. 2 pi k times 5 is not 10k, is 10 pi k. Okay, that's the answer to that problem. Now, Suppose you were asked to solve this problem. How about secant x minus tan x equals cosine x? Now, this looks like a mess, and you're probably right. How about we get this to be just sines and cosines? Secant is 1 over cosine x minus tangent x is sine x over cosine x, and the right side is cosine x. Common denominators are on the left, so it's 1 minus sine x over cosine x equals cosine x. Like always, this times this equals the numerator. That is 1 minus sine x is equal to cosine squared x. Okay. But the right-hand side I can write using sine x's. It's 1 minus sine squared x. In fact, I'll take away the 1's from both sides. So I have minus sine x is equal to sine squared x. Negative sine squared x. I'll bring the sine squared x to the other side, and I get this, and the right side is 0. Factoring, I get sine x times sine x minus 1 is 0. So either sine x is 0 or this is 0, which means sine x is 1. Okay? When is sine x equal to 0? Well, it's equal to 0 at 0 and 180. But no point in saying 360, because I'm going to add 360 to that answer. X can be 0, I won't write, plus any multiple of 360. If k is 0, I get 0. Actually, something's bothering me here. Maybe I even had, no, I don't think I did. It's every 180. 0 times 180, 1 times 180, 2 times 180. It's multiples of 180. That's what x can be. Any multiple of 180. Now, when is it 1? It's 1 only at 90. So x can be 90 plus 360k. Now, I'm not on the left when I have 180k. I'm not adding. See, in the past, what happened was, say it was a half. Here and here. So we got two very different answers. We got 30 and we got 150. And they weren't multiples apart. These are 120 apart, but then the other ones, they're also 120 apart. It was 360 more than that. And it was 360 more than that. $5.10, excuse me. Okay, and again, they're 120 apart. In other words, I had to separate those from these, because these yellow ones, I can say that it's 30 plus 360 plus another 360. I can say 30 minus 360. But when it came to the blue ones, they started with 150. Or I can pick 150 as the starting point. And then it's 150 plus 360. And then plus another 350. Or 160 minus 150 minus 360. But in our case, they're all exactly 90 apart. 180 apart. 0 times 180, 1 times 180, 2 times 180, 3 times 180. 0, 180, 360, 540, etc. So I was able to just say 180K, or 90 degrees plus 360K. So this is the complete answer. The other way of writing it is pi k, or pi over 2 plus 2 pi k. Those are equivalent answers. And that completes this section.